Thank you for watching this video. This is Yuwang from Leibniz Supercomputer Center. I'm responsible for machine learning research and activity here at the Supercomputer Center in Munich. So in this video, I will give you a very brief introduction about deep learning and convolution neural networks. So in the last few years, deep learning and artificial intelligence becomes a very hot topic, even among the common people. And the reason is, in the last few years, there are several breakthroughs in the deep learning research. One of them is in the image classification. So here is a figure produced by Bloomberg. They show that image classification computation hosted by Stanford Vision Lab. So in this computation, a computer program are shown like millions of images. So their task is to classify what the contents are in those images. And the computer made a great breakthrough in 2012 when the AlexNet was invented, and they use basically also the convolution neural networks. And in 2015, the error rate was reduced to like less than 4%, and the computer programs outperform human in image recognition. So that's why they said 2015 is a breakthrough for artificial intelligence. Computers start open its eyes. So what's the secret behind all this success? It's because of convolution neural network, which is already quite old research topic. In 1998, Jan LeCun published this paper on LeNet. He called it LeNet, and it's basically the foundation for all the deep convolution neural networks nowadays. So in that paper, they could do a very nice job already on this like handwriting, digital handwriting classification problems. And the recent breakthrough all comes from more data and faster hardware. So how does convolution works? Mathematically, convolution is just to mix two functions together to produce a third function, basically. So in the context of image analysis, here's a cartoon to show you how the convolution works. Convolution works in a convolution layer of a neural network. So basically, the first matrix is here represent a small image we have, and then the second matrices here is a 3 by 3. It's called convolution kernel, and this convolution, the task of this convolution kernel is to extract certain features out of the original image, and then you have the output matrices there. So mathematically, you overlay this 3 by 3 matrices to the original image and do a sum over all the elements in there. In this case, you can see that the result is -8 because the only non-zero component is these two at the right lower corner. So that the next step is you overlay this convolution kernel across the whole image to produce, for every location, convolution result. That was the feature you extract from the original image. So in a very deep neural network, you have several convolution layers, each trying to extract different features. So visually you can, that's a result, representative result from other paper published in 2013. So basically you have this, imagine this is your neural networks, and that's the feature is extracted on different layers. Each of these layer is a convolution network, and you have different But like in the lower level feature, you have horizontal line and vertical line. Then you have a little bit more complicated features, and then all these are summed up for even complicated features. So the neural network will just trying to extract all these features and to do the final classification task. Thank you very much for watching.